This is the day before yesterday's exam paper question. Uh, Question number 11, combined maths paper 2, right? Uh, VT graph question. In this question, you have two cars. Two cars are given. Car P moves from rest with acceleration 2m, starting from point O, along a straight line path. There's another car Q which moves in in a parallel path with acceleration simple f. But how they start? Car P starts from point O, right? It accelerates up to point A. So you are given that O equals simple A, right? Acceleration is 2m, right? When car reach at point A, let's say time t equals t1, then the car Q start from point O at t equals t1, right, with acceleration simple f, right? It moves, then it continues with acceleration simple f. How do we sketch these VT, these curves for two cars in the same VT graph? Then first car moves like this, car P with acceleration P, right? Then when it comes to point A, it moves same velocity, thereafter no acceleration, it continues with uniform velocity, right? So this is acceleration 2f. So you can take this velocity, maximum velocity is v, right? Then second car, when the car P reach at A, the second car, the Q, start from rest, but it has low acceleration. Therefore, its gradient is less than 2f, so it should be like this. Right? Low acceleration. Then, so at this is the point corresponding velocity equal, but they ask when they use its acceleration, sketch the velocity time graph for the motion P and Q in the same diagram. Hence show that the time taken by Q to the instance when the velocities of P and Q are equal. Velocities of P and Q are equal. What is that equal velocity? Is V. Velocity are equal at this point. Velocity are equal at this point. At point B, these velocities are equal. That equal velocity is V. Then how do you find V? But if you take this O, A, B, so you can name C, P, like that. Now, so you can take this time is T2. At t equals t2, velocities are equal. At t equals t2, velocities are equal. At t equals t2, velocities are equal. Take it as v. Then if you take this point capital D, no need that. Now if you take velocity at t equals t2 is v, how do you find v? But you are given that distance travelled by p up to t1 is simple a. That means this area of this triangle OAC equals to a. Distance OA equals simple a. Distance from O to A equals simple a. It is equals area of triangle OAC. So therefore A equals the half 2V over 2F into V equals A. So from this V squared equals 4AF. V equals square root 4AF. But you need to find at the instance when their velocities of P and Q are equal. So you need T2. You have to find time T2. Therefore T2 equals so this is 2F. So this is V. So you have to find the velocity. You need to find time taken by Q to the instance. Time taken by Q to the instance when t equals t2 is t2 minus t1, that is v over 2a. So this time, right, you need to calculate this time. That time is given by, this is v, so v over 2a. That is v over 2f is v equals 4af over 2f. So this equals a over square root square root A over F, right? Square root A over F. Right. V over 2, sorry, not V over 2F, it's V over X. It should be V over X. So this is it, V over X. So this equals then 2 into A over F. This is acceleration of car Q is simple F. So you have divide V over F. V over F is 2 times square root A over F. Right? The next part they have given that A equals 50, F equals 2. Then what is V? V equals 4 into 50 into 2. Right? So this equals 20 ms minus 1. 20 ms minus 1. Now, so next part you have to find distance AB. The B is the point when you don't take the points on these graphs, right? And the capital B is the point when their velocities are equal on the road, right? That is this velocity. At certain instant, their velocities at point, there's a certain instant, their velocities are equal, right? At certain instance, at that instance, two cars in different places, right? Two cars are different places. Now you will see another point. So you can take that point is t equals t3. At that point is capital B. Both cars at same level, right? Both P and Q at same level, right? That point is capital B, right? Not the point on the graph, on this graph, right? We just let's take that point is capital T equals T3, right? T3, this point. When T equals T3, both cars travel same distance, right? Because at their both same level. So let's take this velocity. You can take this velocity as v1. If you know this velocity v1, you can calculate v1 by equating the distances traveled by both cars, right? When you equate distances, you can remove common part. This common part is, so you can mark this is capital D, E, F, G, right? Now C, B, D, F, G is the common part. If you remove that common part, OCBA equals BDE triangle, right? The area of OABC quadrilateral is equal to the area of BDE, right? Let's see how you can calculate that value. Now if you take now at the instance t equals t3, both cars travel same distance. Same distance. So therefore, area OABC is equals area BDE, right? What is the area of AB? Before that you have to simplify this value. Now you know V equals 20 ms minus 1, FP equals 2. FP equals 2. Now what is the area of area? A equals 50. A equals 50. Now area is equal to now here you can, this quadrilateral you can separate into two triangles. Triangle OAC is equals half into, that is actually A, straight away you can take 50 meters, that is given that. Then other one is this half V is 20, V squared over F. That is ABC triangle, right? So this is 20 over 2, right? 20 over 2 and 2. 20 over 2 into 20, right? Equals, so what is this length? This length is V dash minus V. Now this area you can calculate, this F. So this is V dash minus V divided by F, that is 2, right? Then you can easily calculate half V dash minus V squared by 2. If you simplify this side, 50 plus 100 into 4 equals V dash minus V whole squared. So you will get V equals, this side is 600. So V minus V dash, actually V is 20, V dash minus V equals 6 root 10 root 6. 10 root 6. Plus or minus 10 root 6. But V dash greater than 20, therefore V dash equals 20 plus 10 root 6. But you need to find the distance AB. You have to find distance AB in this. The AB, actually what is AB? AB is distance travelled by Q. Distance travelled by Q when T equals T3. The distance travelled by Q the distance Q when Q passes P, at t equals t3 is equal to area of CF CFE, area of CFE. CFE, that is equal to half into V dash (20 plus 10 root f 40 squared over 2. So this is half V dash squared over 2. So this, if you simplify this one, 1/4 times. So this is actually distance AB. Distance AB equals 1/4 times 400 root 6 plus 600. So this is equal to 1/4 1000 plus 400 root 6, 250 plus 100 root 6. So you can take 50 out. So 5 plus 2 root 6. 50 times 5 plus 2 root 6 meters. This much meter. 5 plus 2 root 6 meter. So that part is over. That is the part A of this sum. Let's see part B. How to do part B? Relative velocity sum, right? This time relative velocity sum, trend of the sum was change. Normal, not previous year's pattern. That trend was changed. Last year also trend was somewhat changed. I think year after they might continue this pattern for the sum, right? So it is specified ship P is sailing due south. Uniform speed 60 meters per second relative to Earth. Ship Q sailing due east with uniform speed 30 root T ms minus 1 relative to Earth, right? Velocities of two ships relative to Earth is given. So you are given that P velocity of P is equal to velocity VPE, it is due south 60 ms minus 1. VQE is due east 30 root 3 ms minus 1. Third ship R. There's another ship move in direction 30 north of east when it is observed from P. That is, velocity of R is given relative to P. That is, VRP is equal to 30 degree north of east. 30 degree north of east. But magnitude is not given, only direction is given. Then it is relative to the velocity of R relative to Q also given. VRQ equals, it moves due south. That means when observed capital R from Q, it moves due south, right? These are the information given. So you have to find, using this information, velocity of R relative to Earth, right? So VRE, so you have to find, this is important, right? So VRE, VRP plus VPE by relative velocity principle, right? You can write this VRP is equal, this is 30 plus VPE is 60. So you can take, this is VRE is, so you can actually you can draw two velocity triangles. This L, you can take Ln, this vector VR equals Ln equals Lx plus Xl. Right. So you can do the velocity triangle for that one. If you take VRE using cap Q, right? VRQ plus VQE. VRQ is given in south, due south. VQE is 30 root 3. So this also Ln, both velocity triangles, the velocity of R relative to E is same. So you can take this also Ln vector, but for these different vectors Ly plus Yn. Okay. Now you can draw the velocity triangle. In this time, we are not asking to draw the velocity triangle same diagram, or you can draw it separately. Better if you draw in the same diagram, then calculation is easy. If you draw in the same diagram, right? You can compare very easily. First, if you draw the Ln, R, Lx is in this direction. Lx 30 degree, Lx Then xn 60. xn this is ln, right? lx plus xn equals ln, right? Now if you take other triangle LYN triangle, other velocity triangle, you can draw in the same diagram like this. So LY like this. LYN. So you can draw two triangles in the same diagram like this. This calculation is easy then, right? You know that this you can draw perpendicular here, right? You know xn is xn equal to 60, right? So yn equals 30 root 3. Then this also 30 root 3, right? Then you know this angle is 30, right? So if you put capital T here, you can take xt tan 30 equals xt over lt, that is 30 xt over 30 root 3 is 1 over root 3. So we get xt equals 30. xt equals 30. If xt equals 30, then tn equals tn also 30. This total length is 60. 60 minus 30 is 30. So this is 30. So this is also 30, right? Now you have to find, so you take theta, then what is theta then? Theta you have to find, and theta and ln, right? You want to find the velocity of r relative to earth, that is ln. Velocity of r relative to velocity of r, capital R, relative to earth is ln. So magnitude of ln, what is ln? ln equals 30 root 3 plus 30 square plus square whole cube square root. So this equals 60 ms minus 1. So tan theta equals xt over tn over lt, that is 30 over 30 root 3 equals 1 over root 3. Therefore theta is an acute angle, therefore theta equals 30 degrees, right? Therefore velocity of capital R is 60 ms minus 1 in the direction 30 degree south of east. So this is the velocity of r relative to earth, right? So what is next part? Now next part, their positions, initial positions are given. Hmm? Initial positions are given. But R and P 20 R is 24 kilometers away from P, the direction 60 degrees south of west. South of west. So it is like this. South 60 degrees south of west. Like that. So 60 degree line normally you have to go like that. So P is here. When P is here, Q is R is here. Right? Then this is 24 kilometers. And P in south of west and 6 kilometers away from Q. Right? It's due south. R is due south from Q. Right? So like this. So Q is here. Now certain position is given like that. So this is 6 kilometers. But you want to find velocity of, now you want to find distance between Q and R. Distance between Q and R when P and R are closest to each other. Right? That is P and R are at shortest distance. When P and R are at shortest distance, you have to find distance between Q and R. Right? So some certain instance positions are given. Right? But you know that P is moving in this direction, but you need relative velocity path. Velocity of R relative to Q is, right? So this is velocity triangle. You know that Lx is the relative velocity of R relative to P. So when P is at peaks, you will see that Lx moves in this direction. So R is moves in this direction like this. This is a path of R relative to P. Right? This angle is 30 degree. This is 30. If this is 30 also, this is 30. Because PRQ is 30, 60 degree. You are given that angle. So this is, you know that this angle is 30. Right? So this is the path of R relative to P. What is the path? Ly is the path relative to Q. Ly. So you see, when Q is, when as seen by Q, the R is moves in a direction like this. So this is the path of, so this is the path of, this is path of R relative to Q, right? When P and Q are at closest, so you can draw perpendicular here. Right? So this is the time. So you can take R dash. When P and R are dash, so you can take T equals, this time T equals T1. Then R, then P and R at closest to each other when T equals T1. You can find time T1 because you want to find the distance between Q and R when P and R at shortest distance, right? So you can find, then let's say distance with respect to Q, R double dash be the position of R when P and R are closest, right? So this is the distance between Q and R when, so T equals, so you can take, this is T equals T1. When T equals T1, relative to P, R is at this point, relative to Q, R is at this point, right? So you have to find distance between Q and R, that is Q R double dash, right? So next part is to find Q R double dash. Now if you take the time taken by Q R, now let's say P R dash equals PR dash equals 24 cos 30. So 20, that is equals 12 root 3 kilometers or 12,000 root 3 meters. This one's PR. Then T1 equals 12,000 root 3 divided by velocity. Velocity, what is the velocity? Relative velocity. Lx. What is Lx? Lx equals, again, 30 root 3 squared plus 30 squared. This also 60. 60 ms minus 1. So you divide by 60, so you will get 200 root 3 seconds. The time T1 is 200 root 3 seconds. Then during that time, relative to Q, R distance traveled by R, right? Then PR equals, PR double dash equals time T1, 200 root T into T times the velocity. What is the relative velocity? That is Lx. Lx is 30. Ly is 30. So multiply by 30. So this equals 6,000 root 3. Then what is QR dash? QR double dash is equals R dash squared plus RQ squared, 4Q square root by Pythagoras theorem, 6,000 root 3 squared plus 6,000 squared. 6 kilometer is 6,000 squared, 4Q square root. So this equals 12,000 meters, that means 12 kilometers. distance between Q and R is 12 kilometers. Therefore, when R is P and R are at closest distance, the distance between Q and R is 12 kilometers. So that is the complete answer for the question number 11. Right?